Welcome to a new episode of the Repair Don't Waste podcast for International E-Waste Day. When we think about e-waste, we often picture old laptops or discarded phones. But for industry, this problem is very different and a much more pressing matter. Behind every factory line, transport network and energy project, there are countless circuit boards working in the background, quietly controlling the operation. But when they fail, companies are left with a choice: repair or replace, often choosing the latter out of convenience. In today's episode, we aim to explore why repair is the better option and the most powerful tool we have against industrial e-waste. In a recent webinar hosted by ABI Electronics, William Santos discussed the need for reform within the maintenance of the renewable energy sector, with some very poignant points that we'll touch on today. In industrial settings, electronics are everywhere, embedded deep inside machines, powering sensors and controlling processes. Yet, they're often overlooked, considered minor components by engineers. Many decision makers responsible for asset management policies don't even realise how dependent their operations are on these boards. That lack of awareness means waste, overspending, and missed opportunities for reuse.
The majority of people responsible for asset management policies, they don't really understand how these systems work. They come to us and say, right, where electronics are used, because obviously they are known, they are classified as minor components. So a lot of people don't actually go looking into them. We had people working from big organizations in the renewable energy sector coming to us and saying, look, I don't actually even have access to the data. We don't know how much we're spending on electronics repair or recovering and so forth, or buying replacement parts. Some of these systems that are used control different sensors from the gearbox. Obviously, sensors looking into air speed, blade speed, and so forth. And then all this is basically done by complex, expensive electronic circuit boards. And we really need to have a think about how we can manage them better in a more sustainable manner.
The reality is that these boards aren't just minor components, but the brains of the operation. And when one fails, the consequences ripple outwards. Entire production lines, transport systems, and energy plants can stall because of one broken capacitor or aging sensor. It's a reminder that industrial electronics, though small, carry enormous responsibility.
Now, because there are so many systems that rely on circuit boards to operate, obviously in themselves represent huge challenges. Supply chain challenges, obsolescence as well is a massive issue. And if you don't manage these challenges properly, your company's profitability will be affected. As I mentioned, these are complex systems. They have been designed by one company and then eventually assembled by someone else and then finished off by a third party. And then eventually they could be running on your machines in Africa, in North America, for instance. This fragmentation in our industry doesn't help much when it comes to understanding and mitigating some of these challenges. But they are designed obviously to last many years, but the components in them, they fail and they age. They can obviously stop functioning properly. And if one device stops functioning properly, you could have a chain of events. So they are subject to lots of harsh environments. Things can go haywire, and it could affect the electronics. And as an operation manager, operation director, you need to be thinking about, if something happens, what we're going to do, how we're going to be resolving the issue as quickly as possible in a sustainable manner.
The scale is staggering. From aviation to automotive, rail to renewables, each piece of industrial infrastructure contains dozens, sometimes hundreds of boards worth thousands each. Multiply that across global fleets and facilities and we're looking at billions invested in electronics. When treated as disposables, those billions quickly become mountains of waste.
As I mentioned, each wind turbine requires between 20 and 30 circuit boards to operate, and they are costly. They are valued between 3,000 euros to 5,000 euros. But if you take 3,000 euros as an average, and then obviously if you multiply that by the number of PCBs that are required to operate a wind turbine, we can run into the tens of thousands per machine. And again, similar situation in the solar energy, with the solar inverters. A solar power plant could have hundreds of inverters, and they all have those systems built into them. But now, if we look into the number of turbines Vestas has in operation currently, 56,000 wind turbines globally in operation, we're now running into the billions of euros invested in electronics assets that obviously they need to last, they need to be kept in operation so that we can extract the most value from them. And obviously, because of the fragmentation that I mentioned before, the cost of the spare parts, especially in the last few years, I've seen a massive increase. Actually, the cost of a circuit board that was before 1,000, now was 3, now is 10. So we have also seen a massive increase in the last few years in the cost of spare parts.
Which raises an uncomfortable truth. How can industries claim to be moving towards sustainability if they're quietly fueling the fastest growing waste source in the world? Throwing away boards because of a single fault is bad economics, and it undermines environmental goals across every sector.
The industry is under pressure, not just to return to profitability, but also to demonstrate that they are really committed to the environment, really committed to sustainability. And you can't really call yourself a green energy company if you are producing e-waste, can you? So that's something that obviously people need to have a think about. If your maintenance strategy is based on just replacing replacing circuit boards and getting a new one every time that something, just one capacitor, one pennyworth part fails, not only you are missing opportunities to learn why this electronic is failing and how you can prevent that failure from happening again, you are adding to the fastest waste stream, the fastest growing waste stream currently, which is e-waste. So we need to do better as an industry to expand the service life of electronics. As I said, they are designed to last many years. Each PCB can be reworked up to 4 times before it has to be taken out of service. And that doesn't mean throwing away. It could be now used as a donor of parts, but potentially even obsolete parts to keep all these systems going for another 5, 6, 10 years. So wasting these precious resources is really a no-go as far as we're concerned. And I think it's, obviously the industry needs to look into that.
The solution needs to start at the design stage. Electronics need to be built with a repair and reuse in mind, not as inaccessible sealed boxes. Standardized connectors, open schematics, and modular systems would make it easier for companies to extend the life of their assets. And if we want a circular economy, then circular design has to begin with the circuit board.
Systems need to be designed for repair. They need to be designed for circularity and for sustainability. And there are many points that I could discuss here, but I have listed there some of the areas that I think the industry can do better. So I think we need to move away from bespoke designs, which obviously makes the operation and maintenance more difficult. I think we need to replace that for, modular designs. We need to think about, standards in terms of connectors, in terms of protocols and so forth. There needs to be an understanding that operators, asset owners, they should have access to at least the bill of materials. So they need to know which components are on their circuit boards. So if they are able to diagnose, then they know which component they should be replacing, like for like, and keeping, the device running at highest value for as long as possible. Schematics, we're big advocates here about, sharing schematics, circuit diagrams to help with the maintenance and repair. The firmware, can we make systems field upgradable? And these are points that we do here at ABI. Yeah, we're not just preaching here. These are core aspects of how we design our own products here at ABI and how we support our customers. So if you have any customer anywhere in the world and they have a 5-year-old system, a 10-year-old system, and they need to repair it, we don't force them to send it here. We charge them a small fortune to have the system repaired here. We first ask, are you capable of repairing circuit boards? If you are, if you want to exercise your right to repair, we're going to help you. We're going to send the list of components that you can buy locally. We can share parts of the schematic so that to help you with the troubleshooting. We can talk you through and give you instructions on how you can repair your system. So if we can do it, I think the rest of the industry, the rest of the equipment manufacturing industry can do that as well. And then obviously tap into the many positive aspects of servitization, which is something obviously potentially for another discussion. But I think you get the point. We need to do better when it comes to designing electronics and make sure that those designing those circuit boards, they are trained for repair as well. If you have a design engineer who's never repaired any electronics and you ask them to design a piece of equipment for repair, how are they going to do it? They don't even know how to start. So again, we need to bring other parts of the industry together, including academia, to help us improve the knowledge overall.
And then there's the issue of obsolescence. In the past, a part might stay useful for decades, but today, whole plants and fleets can launch with critical systems already obsolete. This isn't just a huge inconvenience, it creates waste before equipment has even lived its first life. Proactive obsolescence management, built into industrial strategies from day one, will be pivotal in preventing mass losses in value and resources.
Obsolescence mitigation is another point that if we can do better and improve how we manage obsolescence, we're going to be reducing e-waste so much. And we are part of IOM, an organization that, IOM stands for International Institute of Obsolescence Management. And I have recently been presenting on the aspect of bringing sustainability in obsolescence management and moving obsolescence management from being reactive to being proactive. And I think it's as a concept, obsolescence management needs to be embedded into product specification, manufacturing, use across all the entire life cycle, and not just be a concern when it's too late. And if you do that, if you really think about obsolescence management from the time that an asset is specified, then you're going to start collecting a lot of, important data that will help once the asset is declared obsolete. Obsolescence is a real deal, is a real concern. When I started in my career 25 years ago, something obsolete was, a piece of equipment, made 40 years prior. Yeah. 34, 35, 40 years prior. Nowadays, we're seeing complete wind farms, solar plants, rail systems, airplanes launching with a lot of their vital systems already obsolete. So if you think that obsolescence is something that is not your problems, it's someone else's problem, well, it is your problem as well. And if you want to learn more about obsolescence management, I would recommend people to find out more about IOM. So it's IOM. Search them online, and you can connect with them on LinkedIn as well. Manuela Grunzi is our contact there. She'll be more than happy to, point you in the right direction.
Organisations like IOM play a major factor in strengthening asset management strategies, but repairing electronics in-house day-to-day also strengthens resilience. When companies rely too heavily on new parts or distant suppliers, they leave themselves exposed to shortages, rising costs, and even security risks. Repair brings that control back in-house. It means less dependency, more agility, and a stronger foundation for both profitability and sustainability.
We are big advocates here at ABI for the repair of electronics as being one of the solutions. So it's design, it's obsolescence management, repair, recovery, reuse, before recycling, before we even think about recycling circuit boards. And then what do you stand to gain from moving away from replacing circuit boards to now repairing and reusing them? I have listed there some of the key aspects, and one of them obviously become more independent. You can mitigate some of the issues that I mentioned before much more effectively compared to if you are just relying on third parties, relying on supply chain. If you're delegating your maintenance strategy to a supply chain, and if you let supply chain regulate the pricing, you're not going to be never in control, and it's going to be very difficult to become a profitable operation by doing that. You can limit exposure to cyber risks. You may have seen on LinkedIn, we published a report on this recently based on a piece that was published by Reuters. So they conducted an investigation and found that some Chinese inverters had some rogue components fitted to them, which were capable of being called from home, called remotely, basically controlled remotely, and entire operations could be switched off. Now we don't know if the rogue components were there from the start, or if they were infiltrated when something went back to the manufacturer for repair and maintenance, and then came back with these extra devices. But it is a real risk. Yeah, we have other issues. We have tariffs. We're all seeing what's happening around the world today. If you are again delegating to third parties, and if you were just not really developing a strategy closer to home, then you could be exposed to different issues like that. We're talking about reducing inventory, becoming more agile, becoming leaner, which is incredibly important as well, and ultimately more profitable and more sustainable. A repaired PCB saves about 90% of the cost, produces 85% fewer emissions compared to buying new. So not only have the operational benefits, we also have obviously the financial benefits as well as the environmental issues as well, or environmental benefits as well.
And we've seen how transformative this can be. In Brazil, one technician grew frustrated at seeing viable boards tossed aside. He began repairing them himself, proving to his company how much value could be recovered.
We started a pilot project with GE in Brazil, in the northeast of Brazil, where they had a very good technician who had been repairing without anyone telling him to. He was just like, I'm sick and tired of seeing a lot of PCBs just mounting up and nobody doing anything. We can't just throw away these PCBs because they are worth a lot of money. So he started using traditional instrumentation to do some testing and repair some of these PCBs. And he created so much value that the Latin American operational director took notice and said, right, so we're going to be investing in you, trying to create like a pilot program. What do you need? What would you like to have in your lab? And he said, well, can I ask for a board master? That's my dream equipment. And the director, approved the investment. Long story short, the system was implemented in Brazil, and then GE rolled that solution out to 8 locations across the world to date. And in 4 years, this operation saved GE over $20 million. Now, this came from them being able to diagnose and repair very quickly, especially during the pandemic when we had shortages and some spare parts were on a very long lead time. So they managed to repair those very quickly. Not only they started repairing more and more of their own equipment, but they can also repair third-party equipment. So there's a lot of money in wind or solar plant operation and maintenance, which implies being capable of successfully manage, maintain, operate third-party equipment with no schematics, with no information from and no cooperation from the original manufacturer. So they have been really, successful in using our systems and in bringing repairs in-house. But we have, many other customers working with us in this industry. We have in the solar energy sector, we have Plenium. In Spain, we have Siemens Gamesa, Boralex, EDF that are using our systems to maintain, repair, reuse critical components in the energy generation sector.
That small act of resistance against waste turned into a global program that saved millions. It's proof that change doesn't just come from policies, and this is one of the many companies that ABI has been helping make this shift. Their systems and training empower companies to test, diagnose, and repair boards in-house, enabling organizations to take ownership of their electronics and extend their life cycles.
For those who are not familiar with ABI, ABI was started in 1983, and we're big enablers of repair across multiple industries. We cover over 20 different sectors of the industry, from defense and aerospace to automotive, rail transport, semiconductor manufacturing, biomedical. So these sectors rely on our systems and implement our hardware, software products, and our training, utilizing the board master, which is like an all-in-one solution that can diagnose faults down to the IC level to maintain, repair, recover, reuse their electronic systems. So we don't repair. We're not involved in repairing PCBs. We can't help you with that, but we can supply the equipment and help you overcome these challenges by yourself within your organization in a more sustainable manner.
ABI's contribution to the Repair Don't Waste movement is helping make repair into a necessary workplace cultural shift, a way of rethinking how industries value their assets and their impact on the world. From the design engineer to the technician, from the boardroom to the shop floor, everyone has a role to play in making repair the default, not the exception. So on International E-Waste Day, it's worth remembering industrial e-waste doesn't have to be inevitable. Every board that's repaired instead of replaced saves resources, cuts emissions, and keeps industries moving in a smarter, more sustainable direction. Repairing doesn't just reduce waste, but redefines what responsible industry looks like. And that's a future worth building.